Take a look at number 3. I know what you're thinking. Oh no, it's a different base. Doesn't matter. Base 4 is okay. The hard part is this negative right here. We have to factor that out. So we get the log base 4, factor out the negative, we get x plus 1 minus 2. Remember, we have to factor out the negative to get our b for b hack. So list out your b hack, your transformation rules. Okay? There is a b this time. That, remember, is a horizontal reflection. And that means we're going to go over the y-axis this time. There is an h also. It's plus 1, but we do the opposite, so make it minus 1, and that means we are going to go left 1. There is no a, but there is a k, negative 2, so we go down 1, or 2 in this case. Sorry about that. Very easy. Our parent point, just like before, is 4, 1. Our extra point is always 1, 0, and our vertical asymptote is x equals h right here. But remember, it's the opposite, x equals negative 1. So we graph this. It's always the opposite. I always tell people it's opposite on the inside because it's trying to get out. You have to do the inverse operation if it's inside to get it out. So if it's positive, we make it negative to break it out. So we graph this now. 1, 2, I'll go over a few points here. I like graphing logs. So go over 4. 1, 2, 3, 4. Up 1. There's our parent point right now, and at 1, 0. So if I were to sketch now, it'd be like really wide here, right there. Okay. Graph my vertical asymptote. Hava. And then I transform it. I reflect it over the y-axis, left 1, down 2. So I reflect it over the y-axis, so if that 1 goes to negative 1, go left 1, and then down 2. 1, 2. That's our extra point. Here's our parent point. It reflects it goes to negative 4, left 1, and then down 2. 1, 2. Here's our parent point. Now be careful, it's going to go towards the asymptote, and then it's going to go down, right? And then over here it's going to kind of grow or creep up on it. Now if you notice, there is no y-intercept. We can tell that by the graph. Okay? Or we can actually solve it, like let x equals 0, try let x equals 0, use the original. I get log base 4 of negative 1 minus 2. It's this log of negative 1. That's a D and E. That does not exist. We can't take the log of a negative number. And we can see that graphically why we can't do that, because there's an asymptote in the way, and you can't cross the vertical asymptote. All right, to get the X-Intercept, that's let y equals 0. This is a hard one. 0 equals log base 4 of negative x minus 1 minus 2. Bring over the 2, we get the log base 4 of negative x minus 1. And without going into too much detail, remember, to solve it, we can go 4 to the 2 equals this negative x minus 1. And if you forgot how to do that, that's what the lesson is on in a couple of days. So don't worry about that right now if you forget how to do this. So solving for x, that becomes 16. Add 1 to get 17. Divide by the negative, we get negative 17. Wow, it goes way out there. So our domain, be careful, our domain is switched. It goes from negative infinity to negative 1. And our range, still negative infinity to positive infinity, right there. All right, easy breezy. All right, let's take a look at one more here together. Number 4. Natural log. Now, the thing about natural log is the base is e. So, easy. So, all right, so let's do transformations. I like to call it b hack. It's my rapper name. What up? All right. So, there is no b because I'm not multiplying anything by the x, but there is an h. It's negative 2. We do the opposite. So we're going to go left 2. There is no a because I'm not multiplying by the outside by anything, and there's an a, down 1. Easy breezy. Our parent point is E1, the base 1, and the extra point 1, 0, always. The vertical asymptote, it's x equals h. Do the opposite. X equals negative 2. Again, just the opposite, negative 2 there. And we can now graph this. E1. Be careful when you graph this one. There's E. There's 1, and 1, 0. my vertical asymptote, left 2, negative 2. And now I just do my transformations. Left 2, down 1. This one's pretty easy. Left 2, down 1. But this point's going to be a little bit hard. Be careful of E. It's not quite 3, so if I subtract, but I think it was like 3 though. If I subtract 2, it's going to put me a little bit before 1, right? So 1, 2, right? And then down 1 is actually going to put me on the x-axis. How cool is that? It actually puts me on the x-axis. There's my parent point on the x-axis. So when I sketch it, we can go down, and over here it's going to kind of escape. Don't head it towards the asymptote again. It doesn't bubble over. Alright, this does have an x and a y-intercept, so let's go ahead and find the x-intercept. Let y equal 0. This is kind of a cool one. Watch what happens here. 0 equals natural log of x plus 2 minus 1. Bring it over. We get 1 equals the natural log of x plus 2. Now, remember, the base down here is actually e, so draw a little e there if you need to. This is e to the 1, whoops, equals x plus 2. So we get x equals e minus 2. There's your x-intercept. The y-intercept, let x equals 0. We get the natural log of 2 minus 1. I don't know what the natural log of 2 is, so that's what it is. 0, natural log of 2 minus 1. And we just leave it. Natural log of 2 minus 1. Our range, or domain, sorry, is negative 2 to infinity, and the range, negative infinity to infinity and beyond. Alright, so what I would like you guys to try to do tonight on your own is number 5, okay? Now 5 does have a B on it, okay? So it has a B hack right there. And if you're feeling lucky, go and try number 6, okay? Alright, so we'll take a look at more of these tomorrow, okay? Until then, we'll see you then. Bye.